A gas giant is a giant planet composed mainly of hydrogen and helium. Jupiter and Saturn are the gas giants of the Solar System. The term gas giant was originally synonymous with giant planet, but in the 1990s it became known that Uranus and Neptune are really a distinct class of giant planet, being composed mainly of heavier volatile substances. For this reason, Uranus and Neptune are now often classified in the separate category of ice giants. Jupiter and Saturn consist mostly of hydrogen and helium, with heavier elements making up between 3 and 13% of the mass. They are thought to consist of an outer layer of molecular hydrogen surrounding a layer of liquid metallic hydrogen, with probably a molten rocky core. The outermost portion of the hydrogen atmosphere is characterized by many layers of visible clouds that are mostly composed of water and ammonia. The layer of metallic hydrogen makes up the bulk of each planet, and is referred to as metallic, because the very large pressure turns hydrogen into an electrical conductor. The gas giants' cores are thought to consist of heavier elements at such high temperatures and pressures that the properties are poorly understood. The defining differences between a very low-mass brown dwarf and a gas giant are debated. One school of thought is based on formation, the other on the physics of the interior. Part of the debate concerns whether brown dwarfs must by definition have experienced nuclear fusion at some point in their history. Terminology. The term gas giant was coined in 1952 by the science fiction writer James Blish and was originally used to refer to all giant planets. Arguably it is something of a misnomer, because throughout most of the volume of all giant planets the pressure is so high that matter is not in gaseous form. Other than solids in the core and the upper layers of the atmosphere, all matter is above the critical point, where there is no distinction between liquids and gases. The term has nevertheless caught on because planetary scientists typically use rock, gas, and ice as shorthands for classes of elements and compounds commonly found as planetary constituents, irrespective of what phase the matter may appear in. In the outer solar system, hydrogen and helium are referred to as gases, water, methane, and ammonia as ices, and silicates and metals as rock, because Uranus and Neptune are primarily composed of, in this terminology, ices, not gas. They are increasingly referred to as ice giants and separated from the gas giants. Classification. Gas giants can theoretically be divided into 5 distinct classes according to the modeled physical atmospheric properties, and hence their appearance: ammonia clouds, water clouds, cloudless alkali metal clouds, and silicate clouds. Jupiter and Saturn are both Class 1 hot. Jupiter's a Class 4 of E, extrasolar, cold gas giants. A cold hydrogen-rich gas giant more massive than Jupiter but less than about 500 m will only be slightly larger in volume than Jupiter. For masses above 500 m, gravity will cause the planet to shrink. Kelvin-Helmholtz heating can cause a gas giant to radiate more energy than it receives from its host star. Gas dwarfs. Although the words gas and giant are often combined, hydrogen planets need not be as large as the familiar gas giants from the Solar System. However, smaller gas planets and planets closer to the star will lose atmospheric mass more quickly via hydrodynamic escape than larger planets and planets farther out. A gas dwarf could be defined as a planet with a rocky core that has accumulated a thick envelope of hydrogen, helium and other volatiles, having as result a total radius between 1.7 and 3.9 Earth radii. The smallest known extrasolar planet that is likely a gas planet is Kepler 138d, which has the same mass as Earth but is 60% larger and therefore has a density that indicates a thick gas envelope. A low-mass gas planet can still have a radius resembling that of a gas giant if it has the right temperature.